Welcome back. So last section we talked about erosional landforms, material being carved away by a glacier. The material that was left behind, the shapes that were left behind, are erosional landform features. And those are typically, found up, typically, not always, but more so kind of in mountainous, higher elevation regions. Not always, but typically. Depositional landform features are landforms that are created by material being deposited or settling. So as glaciers carve through areas and move, they bring with it a lot of sediment. As they deposit that sediment, they can create different types of landforms known as depositional landforms. These are kind of at the ends of glaciers, so kind of more so typically, maybe away from mountainous areas at the ends of glaciers. Not always, but typically. So again, formed by deposition of sediment at the margins of glaciers or as glaciers retreat. Some of these features include eskers, drumlins, kettles, kames, and moraines. Not morons, but moraines. So let's talk about some of these. Here's another example, kind of a once-over of all of these features. At the end of a glacier, as it's retreating, it can create some of these features: drumlins, eskers, moraines, kettles, kames. Again, typically away from mountainous regions, maybe even kind of in flatter areas, away from mountains, lower elevations. Not always, but typically. So eskers. So eskers are kind of a long, kind of windy, snake-looking, veiny-looking sediment deposit. The way it was created is as a glacier melts, it melts on top, and sometimes that water makes its way through cracks and flows underneath the glacier. As it does, it deposits sediment as any stream would, so that sediment kind of builds up in these subglacial kind of tubes underneath the glacier. Once the glacier retreats, melts away, that sediment is still left deposited, so we see this on the surface, kind of this raised up ridge, this windy, snake-looking, veiny-looking thing of sediment deposit, known as an esker. This is a stream. That's not what we're talking about. That's a depression. We're talking about this raised up, kind of snake-looking, windy thing. That is an esker. All right, that's an esker. So there was a glacier over this area millions of years ago, hundreds of thousands to millions of years ago, as the meltwater flowed underneath the glacier. In that water, sediment was deposited. As the glacier retreated, melted away, this was left. All right, so that is an esker. A drumlin is an elongated hill in the shape of a kind of a turned over inverted spoon, or kind of the shape of like a half of an egg, and that's formed by glacial ice smoothing out underlying mounds of sediment. So there's some mound of sediment, and then the glacier kind of came in and just kind of smoothed it over, and so what's cool about these drumlins is that they actually help indicate the direction of glacial movement. We can tell which direction the glacier moved as it kind of initially flowed over and carved this thing. Here's a good example of a drumlin. Do you know which direction the glacier was flowing when it carved this thing? If you're looking at this image, it'd be to the right. It'd be this direction, to the right, because we can see it kind of goes up and then it's smoothed out in this direction. So the glacier was flowing, in this case, to the right. So it's a drumlin. Kettle. All right. Kettle is a typically circular-like pothole depression that forms when big melting blocks of ice at the end of a glacier fall off and are left behind, and they get partially buried in sediment during glacial retreat. As that ice melts, it leaves behind this big pit. So here's a glacier. All right, here's a glacier. So the glacier was moving this way, but it kind of stopped, and then it will begin to retreat, so heading back to the right. But as it was melting, big chunks of ice fell off of it. So now you have these big chunks of ice. As the glacier melts, meltwater and sediment comes off and kind of buries the ice, these big chunks of ice. Well, when this big chunk of ice melts away, it leaves behind a depression, a kettle. When this chunk of ice melts, it leaves behind a depression, kettle. Okay, so that's kind of how those work, kettles. Now the hole itself is the kettle. If it is filled with water, then that water is known as a kettle lake. All right, so the depression itself is a kettle, All right, so each of these circular things is a kettle. If it has water in it, it's a kettle lake. It doesn't have to have water in it. This looks like, water that was left over maybe from some snowing event. The material melted and filled in. This isn't glacier water left over. The glaciers here melted hundreds of thousands or millions of years ago. Could be rain, could be snow melt, whatever it may be. So the depression itself is a kettle. The water in it is a kettle lake. All right, so you can see these big circular-like depressions. So all of these were once hundreds of thousands or millions of years ago, big chunks of ice that kind of fell. Those took a long time to melt, but in the meanwhile, material was being kind of deposited around it. That ice melted away, leaving behind that depression. So the opposite of a kettle, a depression, is a depositional landform called a kame. So a kame is a hill composed of sediment that accumulates in the spaces between broken off chunks of glaciers or in a depression on top of a glacier, and then is deposited on the land surface when the glacier melts. So this very same area where this chunk of ice, when it melted away, created a kettle, well, that sediment that was kind of on all sides of it may have created a kame. So kind of the opposite of it, a kame. Kame would become a kame. Or sometimes there's depressions in the glacier itself. Again, as water is melting off and depositing sediment, you can get a sediment deposit. As this big chunk of ice would melt and melt and melt and get smaller and smaller, that pile of sediment would kind of fall down, eventually on the ground, creating what's called a kame. All right, kame. So here's another one. So more so a rounded hill instead of a rounded depression. So the opposite of a kettle is a kame. It could be, just sediment. It could be piles of rocks, but some sort of circular mound or pile of sediment, however big the sediment is. And then you have something called moraines. Not morons, but moraines. So again, as glaciers kind of flow from a cirque, valley, whatever they're doing, as they're flowing, they're carving, they're cutting, they're slicing, they're weathering and eroding that rock. And then they're just pushing all that material essentially to the end of the glacier where it melts. And when that glacier melts, excuse me, allergies. When that glacier melts, any sediment contained or being pushed by that glacier is deposited. And those are known as moraines. Sometimes that material gets pushed all the way to the end of the glacier. Those would be known as end moraines. Sometimes the material gets pushed off to the sides of a glacier. Those are known as lateral moraines. Sometimes, if you can see, here's a good example. This glacier meets with this glacier. You get this moraine in the middle of the glacier called a medial moraine. That's typically occurring when glaciers meet up. They bring with it some sediment, so you get these weird moraines in the middle of the glaciers. So lateral, medial, or end moraines, all the same stuff, just different names depending on where it's at. So here's a glacier. You can see this is the end of the glacier where it melts, but you can see this kind of mound of sediment here. That would be an end moraine. You can also see these kind of ridges of loose sediment on either side here. Those are lateral moraines. Lateral means on the side. Here's an image of a valley glacier I showed you earlier. Again, we have some piles of sediment over here and over here. These are going to be lateral moraines. But then we have these dark bands of sediment kind of flowing through the middle here. So you can see where this kind of valley glacier met up with this larger valley glacier. The lateral moraine, as they meet up, became a medial moraine, a medium moraine, one in the middle. Now we have this ridge of sediment kind of on top of the glacier out in the middle. You can see kind of smaller ones here. Here's another smaller one here. And those are medial moraines. So different types of glacial landforms.